In this video, we'll talk about how to evaluate AI models that create images, sounds, and videos. Imagine watching an AI-generated movie where scenes look choppy or the sound feels off. It would be frustrating, right? So let's explore how to evaluate these models to make sure that the content they generate is smooth, realistic, and engaging. By the end of this video, you'll know how to spot the important ways experts evaluate image, sound, and video AI models. You'll become familiar with the skills to examine and evaluate the media that these generative AI models generate. So, evaluating AI image generation models involves both subjective and objective methods. Subjective evaluations are based on human judgment of factors like visual appeal and emotional impact. Objective evaluations, in contrast, use specialized tools to measure aspects such as image resolution, color accuracy, and the presence of visual glitches or flaws known as artifacts. Consider an AI-generated image of a landscape. To evaluate it, we might use a pixel-based metric like PSNR, which stands for Peak Signal-to-Noise Ratio, to assess image clarity and sharpness objectively. At the same time, we conduct a survey where participants rate the image on realism, beauty, and emotional resonance to gather subjective data. This comprehensive evaluation helps determine the overall success of the image generation model in creating visually appealing and accurate images. Now let's move on to sound. Evaluating AI sound generation models means looking closely at the quality, accuracy, and emotional effect of the sounds they create. You can use objective measurements like spectral flatness and zero crossing rate to technically assess the sound quality. It's also important to gather subjective feedback from listeners on how real and emotionally engaging the AI-generated sounds seem to people. So imagine evaluating a piece of AI-generated music intended to evoke relaxation. Objective analysis could measure the consistency of tempo and the clarity of sound using tools like a loudness meter or a spectral analyzer. For subjective evaluation, a listener group could rate the music on its soothing qualities and emotional effects. Things like that can provide insight into the music's effectiveness in achieving its intended emotional goal. And how about videos? When evaluating AI video generation models, you need to look at two main things: the visual quality of the video and how well the frames flow together over time, which is also called temporal coherence. To measure visual quality, you can use metrics like PSNR that we talked about. This metric checks the sharpness and amount of detail in the video. There's another metric that is called SSIM, which stands for a structural similarity index. This metric looks at the detail and compares the AI video to a reference video. To evaluate the temporal coherence, you want to see how smoothly the video frames transition from one to the next. This helps ensure that the motion in the video looks natural and logical. Another important thing to assess is contextual relevance. Does the video content actually match up with the intended story or scene? The AI-generated video should accurately reflect what it's supposed to be showing. For example, consider evaluating an AI-generated video that depicts a diver in the ocean. Objective metrics would analyze the video's resolution and frame-to-frame consistency to ensure smoothness in motion and clarity in visual details. Subjectively, viewers could assess how well the video captures the essence of the setting, considering the elements like the realism of the ocean waves, the natural movement of the diver, and the overall ambience. This combined evaluation helps determine if the video generation model effectively replicates a realistic and engaging diving experience. In conclusion, Evaluating non-text generative AI models for images, sounds, and videos is essential to advance AI in creative and practical applications. By combining objective measurements with subjective human feedback, we get a comprehensive view of an AI model's capability. This approach ensures the AI-generated content is technically sound and resonates with people, which is crucial for developing useful and appealing generative AI applications.